Product of array except self. I'm just going to explain the solution because I assume you already read the problem. Our test case 1 desired output is 24, 12, 8, 6, and we get that from the array 1, 2, 3, 4. How do we get this? Well, as we know, we get the product of everything else by multiplying all other indices. So for this, for index 1 is 2 times 3 times 4, which is 24. For index 2 it's 1 times 12. For index 2 it's 2 times 4. For index 3 it's 3 times 2 times 1. And so if you think about it, the way that we're intuitively looking at this is that we're going to look at the left and we're going to look at the right and we're going to multiply them together. The first index has nothing to the left but everything to the right. These indexes have left and rights. The last one has nothing to the right but everything to the left. If you think about it, also the nature of product, you can put, instead of saying the left of 3 is 1 times 2, you can just compress it to 2. Or the left of 4 is not 1 times 2 times 3, just put it all into 12, and 6, and put it right here. And so that is kind of the nature of our solution. We have a prefix and we have a postfix array, which we get from processing the nums array. And in order to get our desired output, what we do is we take the prefix array and the postfix array, and whichever index we're currently processing, for example, 0, we're going to look at the prefix array to the left of it and the postfix array to the right of it. So again, we're taking 0 and we're going to steal this number and we're going to steal this number. So this one is index 1, this one's index 0, the actual 0. Technically, if this is the array where it starts, this is illegal, but like we're going to do a trick where we shift everything by +1 and then make 0 our 1 here. The reason for this being that instead of having an empty left side, the first item actually has 1 on the left side, because multiplying 1 by anything gives the exact same thing, so it maintains our product. So we have 1 times 24, which is exactly what we wanted here. 1 times 24. So you may be beginning to see the pattern here. Now for index 1, we take 1 times 12, because we take I minus 1 in the prefix, and we take I plus 1 in the postfix, and we multiply them, which is 1 times 12. So index 2, we take I minus 1 in the prefix, which is 2, and I plus 1 in the postfix, which is 4. And the last one, in index 3, we take I minus 1 in the prefix, 6, times I plus 1 in the postfix, which is 1. This one, again, we shift everything. How do we get the prefix and postfix? We just process it, we just take a cumulative product from left to right, and then for the postfix, we go right to left. And here is like a boxy representation showing how this one's pre-n minus 1, pre-n minus 2, and we play with, in the actual code, well, first off, there's this trick where we do pre-allocation. We don't just create empty arrays and say append. We pre-allocate and fill them with 1s because we know how many slots we need. And then what we do is, for this one, we start at 1. We start at index 1 instead of index 0 because we want this guy. We want this product on the left. Same for the postfix. We start not from n minus 1, which is the last item. We start from the second last item. because again we want to have a right side for every single element. And then at the end we multiply prefix by postfix. In the NeetCode solution, which I'm going to mute.
Imagine being able.
I'm going to mute this so that we don't see that. In the NeetCode solution, he uses the output array as the only array that he's using, and instead uses a single variable to multiply, and that works too. I was initially only using a variable like here, but I was appending to pre and post, so that kind of defeated the purpose. But that is all because there's like a second part in optimization. It says, hey, can you do this in O1 extra space complexity? Key piece of information, the output array does not count as extra space. But I think it's more intuitive to think of it like this before you optimize. And so I hope that this jogs my memory or anybody else's who's watching this video. Thanks.